Randolph Beer is a fun bar located just under the Manhattan Bridge in Brooklyn. Here you'll find neighborhood regulars, nearby professionals looking for a drink after work, and people getting together with their friends, talking over the loud music and the sounds of shuffleboard. Frequently down below, tucked away in a makeshift office and hidden from the bustle, is a bearded man named JR. JR makes the beer, and on this lower floor of the Randolph Brewery, he has the equipment to prove it. Beakers to test the latest batch, a whiteboard full of notes, and tanks full of the drinks soon to be on tap. You might have been on a brewery tour before, but for the uninitiated, here's how JR breaks down the beer-making process.
Grind up some malt, you drown it, you take that water, you boil it, you add hops, and then you cool it down, ferment it.
Got it? Beer is made from 4 basic ingredients: barley, water, hops, and yeast. The basic idea behind making beer is to extract the sugars from grains, usually barley. This is the malting and mashing phase. Here, hot but not boiling water extracts the sugar from the broth-like mash. The mixture is then boiled, hops are added, and the liquid is separated from the solids and cooled down. And then, through a fermentation process, yeast reacts with the sugar to create CO2 and beer. So once again,
you grind up some malt, you drown it, you take that water, you boil it, you add hops, and then you cool it down, ferment it.
A typical day for JR is, well, there is no typical day. On this particular Thursday in July, just before we arrived, he'd cleaned the floor and bought some hops.
I'm a brewery of one here, and I do everything from grain to glass, meaning I come up with the recipe development. I'm the one who does all the buying of the ingredients. I do the whole process in between, and then I'm in charge of it right up to the point where it gets into someone's glass. Exactly, yeah. I mean, I'm not in charge of the glass or filling it. I filled yours, but I'll do that every once in a while.
Full disclosure, we had some beer that day. While JR's brewery is packed with plenty of equipment, there haven't been many technical breakthroughs in beer making. To tell you the truth, JR said, the brewing industry is very archaic in terms of innovation and technology. Much of the beer making process hasn't changed. Take, for example, the production of a particular component of beer called wort.
The actual brewing of the wort production, which is the sugar water, which is made here for yeast, there's not much else that can be done.
This wort process, along with the additional steps of the grinding, the boiling, the adding of the hops, the fermentation, has been the same for centuries. Some folks, however, are finding small ways to innovate. And it's no surprise that the people we talked to for this episode, who are running their own beer, wine, and whiskey operations, are former chemists and engineers. Even JR studied science in college. Nothing special, he says humbly.
Me personally, I have a degree in chemistry before this, but I see a lot of guys who are history majors who are really good.
In this episode, we look at the efforts of vineyard owners, distillers, and brewers like JR, who are discovering ways to adjust their own processes in ways that work for them, to create the beer, wine, and spirits that they love so much. We'll speak with former scientists and engineers who are finding ways to innovate and even make new technologies, using knowledge gained from their previous experience in the lab. Perhaps a background in the sciences is something special, after all. So here's an idea: alcohol.
Oh, cheers, man. Yeah.
As JR mentioned, the process of beer making traditionally involves a series of smaller processes. One of them is fermentation.
Fermentation is, let's see how I can easily put this, I guess yeast metabolizing sugars, simple sugars.
This is where the magic happens, JR likes to say. The wort, which is the sugar water that the yeast will feed on, goes into a cylindrical, conical fermenter.
I just kind of monitor yeast, and I give them food. That's all I do.
From there, the process can take anywhere between 2 weeks to a month. A couple weeks for ales, for example, a month for darker beers. During the fermentation process, the yeast eats up the sugars and creates 2 waste products. Alcohol, yes, but also carbon dioxide, or CO2. A research team from Lawrence Livermore National Lab in California focused on this particular gas. You want the CO2. It's added in later for carbonation. You just don't need too much of it, and breweries create a lot of it. Fermentation produces about 3 times the amount of carbon dioxide needed for carbonation, which just goes to waste.
Most of the time, that CO2 is actually just considered a waste product. It's vented into the air. Some of it is retained inside the beer as sort of a pre-carbonation, but most of it ends up being vented.
This is Lionel Keene. He's a scientist at Lawrence Livermore. He also, in 2016, led researchers in a kind of entrepreneurial boot camp that teaches scientists and engineers the tricks of the trade as they spin out technology from the lab to the marketplace. One of those proposed technologies, carbon capturing microcapsules. The microcapsules basically look like really tiny sushi rolls. The beads have a semi-permeable membrane, a polymer shell, on the outside, and in the center are reactive chemicals, which trap the waste gas and store it.
You can picture these microcapsules as sponges. So if you use a sponge to, say, get water out of dirty water or the mixture of water with something else, and then you get another bucket and you squeeze out and water comes back out. And these microcapsules pretty much do the same thing, and they're fully recyclable because the materials we use in there are very durable and they pretty much last forever.
This is Kong-Wang Yi, or CW. He participated in that entrepreneurial boot camp known as the LabCorp pilot program. CW currently produces the microcapsules and analyzes them to make sure they have the right formulation. One way to make sure they were on the right track, they visited breweries, from the little local craft operations, sometimes literally one person in a room with a couple barrels and buckets, to the mega beer makers like Coors, whose facilities look almost like an oil refinery. By meeting with Coors and a local CO2 supplier, Keen and CW learned that Coors generates roughly 300 million pounds of carbon dioxide per year during the fermentation steps, but only uses 80 million pounds, most of which is currently purchased through suppliers.
We looked at the Miller Coors operation in Golden, and they literally had tanker trucks coming in every day full of compressed carbon dioxide. The consumption of CO2 for that operation was, well, it's a giant operation anyway, but the amount of CO2 they were using to purge all their bottles, carbonate all their beer, it was enormous.
In order to handle such large amounts of carbon dioxide, Coors had its own carbon capture system, a combination of gas balloons, gas washers, CO2 compressors, and a carbon filter, placed at the top of the fermenter. To reclaim the CO2, such a system had to be used on a grand scale, one that might work for a mega brewery like Coors, but be way out of reach for the smaller operations, with the barrels and the buckets. After visits with microbreweries, however, the two discovered that while Coors had the resources to capture and reuse carbon, it was too expensive for craft producers, making less than 500,000 barrels. CW and Lionel Keen thought that they had the technology that could allow smaller breweries to capture and reuse the CO2. What they could use were CW's microcapsules. Instead of purchasing CO2 from a local supplier, CW thought, breweries could implement the microcapsules to capture and reuse the extra gas. This would make the breweries self-sustaining, and they could sell the excess to other nearby consumers. Lionel and CW noticed that often breweries simply stick a tube from the fermentation tank into an ordinary bucket of water to catch the gas. The Livermore laboratory researchers saw that they could easily replace that bucket of water with a tank full of the carbon-capturing microcapsules.
What we were proposing actually was not novel in a true sense. I mean, you can buy carbon capture systems that are designed to work in our brewery. The problem is the cost is so high that only the largest breweries around can afford to install a system like that. So where we came in was we were proposing to do something on a much smaller scale and much more affordable. And when people at these smaller breweries heard that, you could see the excitement in their faces. They really liked the idea.
The basic idea of the CO2 capturing system is to use barrels filled with millions of microcapsules that could absorb CO2 from the fermentation process. In theory, CW's company would provide the equipment at no cost up front, the brewers would collect CO2 gas from the fermenters, fill the tanks, and CW's crew would send trucks to pick them up. The captured CO2 would be reclaimed at a centralized hub and sold back to brewers at a big discount. The surplus would be sold on the open commodities market. Though there has been some private interest, CW's technology needs to mature somewhat before it is officially implemented in breweries like JR's. While applying for funding from the Department of Energy, CW is also shopping the smaller-scale carbon capture technology around to craft breweries. He's also in discussions with UC Davis, which has a pilot-scale winery and brewery, to install the system to prove the concept works. The idea could potentially save breweries tens of thousands of dollars a year, Keen said. And green has its own kind of appeal.
From a marketing standpoint, there's cachet associated with being able to say, we don't inject industrially sourced CO2 into your beer to carbonate it that you're drinking right now. All the carbonation in our beer is a direct result of the beer that was produced here on site, 100% natural.
Beer begins with grains, which are then fermented. Wine is basically the same idea, except you're using grapes. The grapes are crushed, and yeast is added to the juice, eating up the sugar until there's none left. The end result is wine. From there, it's up to the winemaker regarding how long to age it, where to store it, and when to bottle it. Russ Hamilton and his wife Stacy had a dream to own a vineyard on Red Mountain, in the southeast corner of Washington state. In 2014, that dream came true. They formed Hamilton Cellars, an operation that has produced a number of award-winning wines in festivals and competitions around the Washington area.
I have a 10-acre vineyard. It's roughly a third Malbec. We have 7 different Malbecs. That's what we specialize in. It's a third Cabernet Sauvignon. And then the remaining third is split up between Merlot, Cab Franc, and Petit Verdot, which are all Bordeaux grapes. The only Bordeaux red grape I don't have is Carmenere.
This is Russ. He began his career as a chemical engineer with Chevron, specializing in petrochemicals. He then spent 14 years in the semiconductor industry.
I was an engineer too long and it burned my brain up. So now I like going out and trimming vines and, cleaning up weeds and tying vines up that have blown off the trellis and that type of thing.
More than 10 years ago, he and his wife, an accountant, had decided it was time to switch careers and get a winery up and running.
My wife and I have always enjoyed drinking wine, and we, in 2005, were enjoying wine on a deck at a very nice winery in the Walla Walla area. And we're also talking about what do we want to do when we retire, because we did not like typical retirement things, but we did like travel and we liked wine. So all of a sudden we said, let's build our own winery. So that really triggered everything. Our first vintage was 2006. We didn't release it until 2011 due to some issues of building a facility. But we enjoyed doing that. I was involved in engineering, and my 14 years in the semiconductor industry, I was responsible for building 3 different facilities for 3 different companies that were about $7 billion. So I had a lot of project management skills and things of that nature. My wife is a CPA, and she definitely understood the business side. So we got into this in pretty good shape as far as having a good knowledge. We knew we weren't winemakers. We knew we couldn't grow grapes, so we went out and hired the best people in the area to make our wine and tend to the vineyard.
For a wine professional with a chemical engineering background, Russ wanted his vineyard to stand out, not just for its awards, but for its energy efficiency as well. He had a specific number in mind: 0.
One thing I wanted to do was to be different and be what is called a net zero winery, so that all the electricity I use in the vineyard for irrigation, which is substantial, and up in the production building and tasting room, I would generate or save somewhere in the facility. And to do that, we installed 151 solar panels on the roof of the winery building. The generate actually is designed for 55 megawatts a year, but I'm going to do more than that this year because the weather's in my favor.
The solar panels run the well pump. The well pump also contains a motor control known as a variable frequency drive, which operates just fast enough to put out the exact amount of water needed. Solar thermal technologies create the hot water required in the tasting room and the winery.
All our lighting is LED. Just to add to the renewables, I have 4 electrical vehicle chargers here that I provide electricity for free to customers. 2 are Tesla destination chargers, and 2 are what's called a level 2 EV charger. So we have, just a half a dozen other little small things, but those are the major things. But overall, in the course of a year, I will generate what I use.
The idea of sustainability and energy efficiency was in mind from the very beginning. The initial setup, in fact, wasn't even close to being net zero until Russ added 30 more panels than he had planned for in the original design. His electric car sits right beside a 1946 Chevy half-ton pickup truck, a representation of the old versus the new.
Some people have solar panels. The variable frequency motors in irrigation are somewhat common now. A lot of people are doing it. It saves at least 30% of the cost of electricity and running a pump. I don't see anybody really with a commitment I have. I'm sure they're out there. I've seen a couple in California in the Sonoma area that appeared to be pretty close. So, it's a matter of what your commitment is.
A similar level of commitment, however, is happening just a few miles east of Russ's Hamilton cellars. But instead of wine, it's whiskey. Beer is brewed from barley malt, with maybe some other added grains. Wine is brewed from the juice of grapes. To make spirits, however, the process features an additional step, and the beer or wine must be purified further in a process known as distillation, where a mixture is heated, evaporated, cooled, and condensed, extracting a purer form of the alcohol. Jim Batdorf is very familiar with this. He is the chief distiller at Solar Spirits in Richland, Washington. Jim makes vodka, gins, a variety of fruit-flavored brandy, and whiskey. All of these are made following the same process, using local produce as a starting point and beginning with wine. Here's Jim.
So everything starts as wine, and then we go through a large still and do a stripping run. This is fairly common in craft distillers. So you take the wine at 14% alcohol, run it through the first still in a batch mode, and concentrate up to 40% alcohol. Then, depending on where you're going, that alcohol is treated in one of two different stills. So either we do multiple runs until I have enough to refill that large still. Cranberries are grown in western Washington, over by the coast, and we make cranberry wine. It's an unusual starting point, and it was just because one of the partners had relatives there, and they said, "Oh, we have cranberry wine here. You should make some cranberry brandy." Well, we also took some and made vodka, and it turned out to be really a really great vodka. The reason for that is probably due to the cranberry itself.
Much like Russ Hamilton and JR from Randolph Beer, Jim Batdorf started his career as a scientist. He worked at Inintech for the past 15 years. Inintech developed a new technology for processing solid, liquid, and gaseous waste materials and converting the waste materials into hydrogen.
My background is chemical engineering. I have a PhD in chemical engineering. I've worked in process engineering, technology development, waste to energy for over 30 years. In 2015, I was working part-time and kind of taking a little bit of a breather and trying to figure out what I wanted to do when I grew up. And met these gentlemen that had started this distillery and were looking for a distiller. So I said, well, I know about distillation and I like whiskey. It seems like I can become a distiller.
Founded in 2015, Solar Spirits incorporates a mash and distilling process that is supported by thermal solar tubes. Sip sustainably, says the company's website.
It's very important to our company. Solar Spirits started with this idea of incorporating solar, but as we've evolved, we are looking more and more at how we can take our company and make a sustainable business. This year, we are buying renewable energy credits, so we've gone 100% renewable for our energy supply. Anything that we use energy for lighting or heating and air conditioning in the tasting room, in the distillery, all of that now is powered by renewable, over and above what we can provide with our solar panels. But we're also going through every aspect of our business operations, trying to reduce plastic use, trying to think about the environment and sustainability as we go.
Solar Spirits uses hot water to extract the sugars during the mashing process. They also use hot water to clean the equipment. How much exactly? Initially, Jim used 2 300-gallon hot water tanks.
Since then, we've modified the system, and I've converted it over to a hot oil. So it's a thermal oil that flows through that header and is heated by the sun's energy. And then we connected that into the system that heats our stills. So we have a recirculating system of hot oil. It goes through an electric heater to trim the temperature. and it goes to the stills. I have 2 different stills that are connected in.
Jim has an array of 12 solar thermal panels. Each 4 by 5 foot panel contains a series of tubes that are about 2 inches in diameter and 4 feet long. The sun's energy goes through those glass tubes, collects the heat, and the vacuum space keeps the thermal energy from leaking out.
So you get a really efficient system, and it's good for the sun going through, a lot of angles as it moves through the day. You don't have to rotate or move these panels. Here in Richland, we get 300 days a year of sunshine, so it's a good option for us.
And Jim's distillery looks in many ways like a traditional distillery.
If you walked in, you wouldn't really notice any difference at all. You see some pipes running through, but they're fairly small, and they don't really, it wouldn't be obvious to anybody. But the one thing running on hot oil does that was sort of unexpected is that it provides for a really precise control of the still. Most people heat their stills with steam, and steam has a lot of safety issues, which means that people operate at fairly low pressure steam to keep it simple rather than in an industrial setting or a chemical plant. That basically means you're kind of on or off. You're always going to be operating at that one temperature, which is about 250 Fahrenheit. With the recirculating hot oil, we can operate at 120 Fahrenheit, 140, 180, 200, any point in between. And it gives us a great deal of control.
So when you're making beer or wine or whiskey, does it help to have an engineering or science background? That depends on who you ask. Here we are again, back with JR at Randolph, about 1 beer later.
I've noticed, at least the few people we've talked to, there's been an overlap with an engineering background, and then the sort of...
Or science.
Yeah, or a science background. Do you find that a lot of your peers and colleagues have that kind of background, or do you... Okay, no.
But JR does have that chemistry degree, and he has an engineer's mind, with plenty of toys and inventions in his workshop below the bar to aid his brewing process. He showed us a few of his own inventions, gadgets he's made like a keg fermenter he turned into a single-vessel yeast propagation system, and a peristaltic pump he now uses to cleanly introduce fresh wort. So beer, wine, and spirits are being made much in the same way they've been made for centuries. The difference is, each brewmaker, winemaker, and spirit maker can use their specialized knowledge and what's available to them locally to help them support sustainable practices. They can tweak their systems and tailor them for their own specific workflow. JR can make his own peristaltic pumps. Microbreweries can reduce greenhouse emissions by giving carbon capture a try. Jim Batdorf can use thermal panels to replace hot water tanks. Russ Hamilton can use variable frequency drives to support his irrigation wells. They're not reinventing the wheel, they're not reinventing beer. But just as JR can put his own take on a traditional recipe, engineers can put their own unique spin on a traditional process. This has been an episode of Here's an Idea. I'm Billy Hurley for Tech Briefs Media. To learn more about all kinds of innovative technologies, you can follow our stories every day at techbriefs.com. Here's an idea. Write us a review on iTunes. We'd like to hear from you. Let us know what inventions you'd like to hear more about, and email us at feedback@techbriefs.com.